Second problem. First, the wide sense stationary means a stochastic process x of t its mean is equal to eta, which is a constant, and the autocorrelation of t1 to t2 is the autocorrelation of tau, where tau is t2 minus t1. That means the autocorrelation of a wide sense stationary process is only depend on the difference of t2 and t1. The second process is the independent increment process. If the increment x of t2 minus x of t1 and x of t4 minus x of t3, these two increments are independent, then we have for any t1 minus t2 larger than t2, larger than t3, larger than t4, we call this process is the x of t is independent increment. X of t is a stochastic process, so this process is independent increment process. We know Poisson process is a process with independent increment. That means if the interval t1 to t2 and the interval t3 to t4 has no intersection, then we call the increment of x t2 minus x of t1 and x of t4 minus x of t3 are independent increment. The third process is the Markov process. Markov process is means the following: the probability of x of t1 less than or equal to x1 given x of t2 is equal to x of 2 and dot all the way to the x of Tn is equal to x of n. This probability is equal to the probability of x of T1 less than or equal to x of 1 given x of T2 equal x of 2. So that means f suppose we have Tn minus 1, Tn minus 2, T2, T1, where we have T1 larger than T2 larger than dot 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 larger than Tn. The latest data at x of T1 only depend on the data of x of T2, does not depend on other times value, other data like x of Tn, x of Tn minus 1, etc. Does not depend on this. The fourth process is strict sense stationary. A process x of t is called SSS if its statistical properties are invariant to a shift, invariant to a shift of origin. That means the process x of t plus c is a constant, is equal to, and the process of x of t have the same statistics for any c. It's a little like it's like the time invariant property. Time invariant property we learned in the linear system, and we know the PDF of x of t1, x of t2, x of 2 dot 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 x of n, t1, t2 dot 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 tn is equal to f of x2, x1, x2 dot 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 x of n, t1 plus c, t2 plus c dot 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 tn plus c. The last process is white noise. A process V of t is a white noise if if its value v of ti and v of tj are all uncorrelated, for any t and tj which is not equal to ti, that means the correlation function of ti and tj is equal to 0 when ti is not equal to tj. That also is equal to q of ti delta ti minus tj, where q of ti is larger than or equal to 0. Now this process, the process at ti and tj does not depend on each other. They are uncorrelated with any other time ti is not equal to tj.